Alright. Principles and process of conducting life cycle cost analysis. Part 1, life cycle cost analysis introduction. Alright, introduction. Life cycle cost analysis is a method of assessing total cost of facility ownership that takes into account all the costs of the acquiring, owning, and the disposing of the building and the building system. Life cycle cost analysis is especially useful with a project alternative with the fully same performance requirements but differ with respect to initial cost, operation cost. Have to be compared in order to select one of the maximized net savings of the life cycle cost analysis will help determine with the incorporation of high-performance HVAC glazing system, which may increase the initial cost, but result dramatically reducing operation maintenance costs. Cost effective of the life cycle cost analysis not useful with the budget allocation. Lowest life cycle cost is the straightforward, easiest interrupting measure for the economic evaluation. Some of the commonly used name measures in net savings or net benefits. Saving to investment ratio, saving the benefits to the cost ratio, internal rate of return, payback period consistent with the lowest life cycle cost measure for the evaluation. If they use the same parameters, length of stay period, building economics carefully value specialist cost engineering, architects, quantity surveyors. Operation research others that may use any of the several other techniques to evaluate the project. The approach to taking cost-effective choice of building-related projects can be quite similar whether it's called cost estimating or value engineering economic analysis. Alright, description. Life cycle cost analysis method. Purpose of the life cycle cost analysis is to estimate overall cost of the project, alternative to select the design and ensure the facility will provide lowest overall cost of the ownership consistent with the quality function. Life cycle cost analysis should be performed early in the design process where it still has a chance to refine design, ensure reduction of life cycle costs. First and most challenging task of life cycle cost analysis economic evaluation method, determine the economic effects of the alternative design building systems, quantify these effects, express them in dollar amounts. Alright, B, cost. The numerous costs acquired associated with acquiring, operating, maintaining, disposing of the building and the building system, building-related costs usually fall into the following categories: initial cost, purchase, acquisition, construction costs, fuel costs, operation, maintenance, repair costs, replacement costs, residual values, resale, salvage values, disposal costs, financing charge, loan, interest payments, monetary benefit costs. Only these costs, which each category relevant to the decision, significant amount of the need to make the valid investment decision costs are relevant to that which they are different from the one alternative compared to another. Costs are significantly large enough to make credible difference of the life cycle cost project alternative. All costs are entered in the base year amounts, total dollars. Life cycle cost analysis method escalates to all amounts of the future year with the currency discount that back to the base date and then to convert the present values. Initial costs. Initial costs may include the capital investment cost, land acquisition, construction, renovation, and the equipment needed for the operating facility. Land acquisition costs need to be included in the initial cost estimate if they differ among the design alternative, in which case the example compared with the cost renovate existing system, facility, new construction, purchase land. Alright, construction costs. Detailed estimate construction costs are not necessary in preliminary economic analysis. Alternative building design systems, such estimates are usually not available to design and advance, and opportunity for cost reduction design changes have been missed. Life cycle cost analysis can be repeated through the design process. Detailed cost information become available. Initial construction costs are estimated reference historical data from similar facilities. Alternatively, they have been determined by the government and private sector cost estimating guides and database. The TRISER, the parametric estimating system, or TEPS, develops buildings, different facility types to determine the critical cost parameters, numerous floors, area, volume, percent, permanent length. Letting these values with the algebraic formula predict the cost of the range of the building system, subsystem, and assemblies. Detailed cost estimates are prepared for the sub-middle stage of the design, typically 30, 60, 90% based on quantity of the takeoff calculations. These estimates rely on cost database, such as commercial unit price book. Testing organization ASTM, international trade organizations have reference data material products of the test present represent. Energy and water costs. Operational expense of the energy and water other utilities based on the consumption current rate with the price projection basic as energy with some of the extent. Water consumption building, construction building envelope, and interdependent energy and water costs are usually assessed by the building whole rather than individual building of the components. Energy uses. Energy costs is often difficult to track accurately with the design phase of the project. Assumption must be made with the use of the profile occupancy rate for the schedule with which the energy consumption, initial design stage data for the amount of the energy with consumption for the building came from the energy analysis computer program eQuest Energy Plus DOE2 require more detailed input but not available until later design. Other packages such as the Priority Trace and 3D Plus, ESPRE, EPRI, and HAP Carrier have been developed such to assist mechanical equipment selection and sizing with the different distributed by manufacturers. When selecting a program, it is important to consider the natural need of the annual, monthly, hourly energy consumption figures, whether the program adequately tracking some of the energy consumption design choices different efficiencies level and stimulated. Energy prices, quotes, and current energy prices from local suppliers should take into account with the rate of the type of the rated structure, summer and winter differentials, block rates, demand changes to obtain the estimate and the close over the possible of the actual energy cost. Energy price projections. Energy price are assumed to be increased with the decreased rate different with the general price inflation. Different energy price escalation needs to take into account with the estimating future energy cost of the energy price projections can be attained either from supplier or from energy price escalation published annually with the April 1st Department of Energy discount factors of the life cycle cost analysis annual supplement NIST Handbook 135. Water costs should be handled much like energy costs. They must have two costs, type of cost, water costs, water usage, water disposal costs. Department of Energy does not publish water price projections. Operation, maintenance, and repair costs, non-fueling operating costs, maintenance of the repair costs are often more difficult to estimate other than building expenditures. Operating schedules stand with the maintenance from building to building. This is great variation of costs even with the same type and age. They are therefore equally important even the engineering judgment when estimating the cost. Supplier quote and published estimating guides provide information on the maintenance repair costs. Some of the destination data estimations guides derive costs from the statistical relation with the historical data means of the BOMA. For example, the average owning operating cost per square feet for the type of the building, geographic location, number of stories, number of square feet, and building Whitestone research facility maintenance and repair cost reference gives analyzed cost building systems elements all service estimates specifically building components. U.S. Corporate Engineering Huntsville Division provides an accustomed OMNR database for military reconstruction. Replacement cost, number the timing and the capital cost of the building system depends on the estimated life and length of the study of the period. Use the same sources for estimate with the initial estimate. Obtain estimates and the replacement cost expected useful lives. Good starting point. Estimating future plate replacement costs is there for the cost of the base date. The liquid life cycle cost analysis method will escalate based on base year amounts for their future time occurrence. Residual value of the system component, remaining value at the end of the study of the period at the time of the replacement during the study period. The residual values can be based on value place, free sale value, salvage value, scrap value, and any selling conversion disposal costs. As a rule, within the residential value system will remain useful in place. Useful life in place be calculated linear prorating initial cost. For example, for system when expected useful life of 15 years was installed 5 years before the end of the study period, residual value will be approximately 2/3 of equal 15 minus 10 divided by 15 for the initial cost. Other costs, financing charges and tax. Federal project financing changes usually not relevant. Financing charge and other payments apply over the project's force for the energy savings performance contract, utility energy services contract. Financing charges usually include contract payments negotiated with the energy service company or utility. Non-monetary benefit costs. Non-monetary benefit costs are project-related effects which have no objective way of assigning a dollar value. Example, the non-monetary effects of the benefit derived from quite havoc system expected hard quantity product gained due to the improved lighting by nature. The effects external with life cycle cost analysis, but if they are significant, should be considered a final investment decision included. Project documentation. C. Cost-effective considering non-monetary benefits such as aesthetic, historic preservation, security, and safety. To familiarize your inclusion non-monetary cost benefit decision making, you can use the analytical higher process to use one of the self-multi-attributive decision analysis methods that consider the non-monetary attributes, qualitative and quantity, in addition with a common economic valuation measure, valuation project, alternatives, ASME 1765 standard practice applying analytical hierarchical process, multi-attributed decision analysis, investment related to project products and process, published ASTM internal procedure, calculating, interpreting, analytical hierarchy process score over the project overall disability when making the building related capital investment decision, source of information estimating productive costs, for example, the whole building design guide, product productive chain. Alright, C parameters, present value analysis, discount rate. In order to be able to compare with the flow of the curve with the different times during the life of the cycle of the process, you have to make the time and the equivalent, make the cash flow time and the equivalent life cycle cost. Method that converts to the present value with the discount with a common point of time, usually with the base date, with the insurance rate, with the discount. This rate reflects inventory opportunity with the cost of the money over time, meaning in the investment warrant to achieve the return at least high as well as the next best investment. Hence, the discount rate may represent the investment minimum acceptable rate of return. Discount rate for the federal energy water conservation projects are determined annually by FEMP. The other federal projects are non-primary with the concern with the energy water conservation discount rate with the official management budget. Discount rates are real discount rates not include the general rate of inflation, cost period, length of study period, with the study period beginning with the base date of the date to which all flows are discounted with the study period, include planning, construction, and implementation period with the occupancy period with the study with the period of the same alternative considered. Service period begins with the completed with the building and occupied within the same system is taken into conservative. This period is over which operational costs become benefits evaluated to FEMP analysis. Service period is limited to 40 years. Contract period is the contract of the period the ESPC ESC project live with the study period of the term of the project formally accepted. Energy saving to be accrued with the contract payment that begins to do with the contract period generally ends the loan paid off. Discount convention. The office management budget FEMP studies initially are all annually require cash flow. And are discount for the end of the year, which they are included with a mill count study with a discount for the middle year. All signal amounts are discounted from the date of the occurrence. Treatment of inflation and life cycle cost analysis can be performed in the constant dollar or current dollars. Constant dollar analysis exclude the rate of the general inflation. Current dollar analysis include the rate of general inflation, dollar amount, discount rates, price escalation rates. Both types of calculation result in identical present value of life cycle cost. Constant dollar analysis recommended all federal projects. Project finance, private sector, ESP, UESC. Constant dollar method advantage if they do not require estimating rate of inflation a year of the study period. Alternate financing studies usually formed in current dollar analysis wanted to compare contract payments to actual operational energy cost savings from year to year. Alright, D, life cycle cost calculation. Early after identified costs about a year amount with the discounting of the present value, they arrive at the total life cycle cost for alternative. Life cycle cost is 1 plus REP plus E plus W plus OMR plus O. Life cycle cost, total life cycle cost, present value, dollars and general alternatives. I, present value, dollars investment cost. REP, private value, capital replacement, private value, residual value, less disposable cost. E equals private value, but the energy cost for the W equals PV, water cost. OMR equals PV, non-fueling operations, maintenance and repair. O equals PV, other than costs, other costs. E, supplementary measures. Supplementary measures, economic evaluation necessary with saving the investment ratio, acquired interest rate of return, simple payback with a discount payback for the sometimes needed to meet the specific regulatory requirements. For example, FEMP, life cycle cost, Title 10 CFR 436 subpart A requires the use of SIR, AIRR, ranking independent projects completing in limited funds some of the federal programs payback period. To compete with the screen measures of the project evaluation, NSSI or AIRR consistent lowest life cycle cost alternative the computed with the all applied correctly. Same type of adjusted input assumptions payback measures, but either SBD, simple payback, or discount payback are accrued consistent with life cycle cost analysis calculated over the entire study period, not only for the years of the payback period. All supplemental measures relative to the measures that compute with the alternative relative to the base case. NS if the necessity of the operational savings less the difference of the capital investment. Savings and investment ratio, operating savings difference case, capital investment, AIRR, or adjusted initial rate of return and annual yield alternative other study period taking account with the reinvestment of the interim returns of the discount, SBD, simple payback required with the cumulative of the savings alternative to recover the initial investment costs, other accrued costs without taking into account the value of the discount payback at time required with the cumulative savings alternative recovery, initial investment costs, other accrued costs taken account with the time of the value of the money. Hard evaluation criteria, lowest life cycle costs, uncertain assessing the life cycle cost analysis. Decision about a building related to the investment typically involved with a greater deal of uncertainty about their cost potential savings. Performing life cycle cost analysis greatly increase likelihood of choosing with the project save money in the long run. You may thereby uncertainly associate life cycle cost result. Life cycle cost analysis are usually performed early in the design process and only estimate the cost of savings are available rather than certain dollar amounts used necessary. Uncertain input values mean the actual outcomes of the different estimated outcomes. There are techniques for estimating costs. Choosing wrong project alternative with different techniques such as sensitive analysis, breaking even analysis, easily done without requiring an additional resource of the information producing a single point estimate how uncertain input data affects analysis outcome probabilistic techniques, and on the other hand quantify the risks both of dividing probabilities of achieving a different value of the economic worth or the probability of disruption input values is uncertain. However, the greater information on the technical requirement to determine the deterministic techniques, whether one or other techniques chosen depending on the factors inside of the project and its importance are all resource available. Sensitive analysis, break even analysis to approach the simple perform. They should be part of the life cycle analysis. Sensitive analysis, sensitivity analysis technique recommends energy water conservation projects by FEEMP. Sensitive analysis is useful identifying with the number uncertain of the input value with the greatest impact specific to measure the economic valuation, determining how variability input value affects the change of the range of measure of the economic evaluation. Testing different scenarios to answer what if questions, to identify critical parameters arrays, estimates upper and lower bounds, and answer what if questions similar to change value, each input up and down holding other constant and recalculating economic measure to be tested. Pre-breaking even analysis, decision makers sometimes will want to know the maximum cost of the input allowed with the project to break even. Conversely, with the minimum benefit the project produce and still cover cost investment, the break-even benefit cost equal the variable specified with the break-even variable selected algebraically. Sensitivity analysis, break-even analysis, number the approach of the risk uncertainty assessment, both deterministic, probabilistic, describing techniques of trading, uncertainty, risk, and economic evaluation, building investments. Design analysis tools. Use the computer programs considerably reduce the time and the effort spent on formulating the life cycle cost analysis, performing computations, documentation study listed below. Life cycle cost analysis related software program. Building life cycle cost program, economic analysis developed in the National Institute of Standard Technology, U.S. Department of Energy Federal Emergency Management Program. Energy Management Program. Application life cycle costs can be applied with a capital investment decision relatively higher initial cost with trade-off of select future obligation, particularly suitable the evaluation, building design, alternative sensitive that satisfy with the required level of the building performance of many of the different initial payment costs, differing operating maintenance repair costs with the possibility of different lives. Life cycle cost analysis provides significantly better assets, long-term cost effect of the project, alternative to the economic methods focus first cost for the operating related short-term run. Life cycle cost analysis performed on various levels of complexity. Simply, scope of the might vary with the back to the envelope study with the detailed analysis through the reach for the input data supplementary measure, economic evaluation, complex uncertainty assessment, executive documentation, extraction, sensitiveness effort should be tailored for the needs of the project.